I've been working in this area for quite a while. The chairman of my doctoral committee was one Marvin Minsky. We had some discussions on AI safety around 1990. He said I should write them up. I finally got around to writing some developed version of those ideas just very recently. So that's some fairly serious procrastination. Decades of procrastination on something important. But for years, one couldn't talk about advanced AI. One could talk about nanotechnology. Now it's the other way around. You can talk about advanced AI, but not about advanced nanotechnology. So this is how the Overton window moves around. So what I would like to do is to give a very brief presentation, which is pretty closely aligned with talks I've given at OpenAI and DeepMind and, of course, FHI, Berkeley, Bay Area rationalists, usually with a somewhat smaller number of people and structured more around discussion. But what I would like to do still is to give a short talk, put up points for discussion, and encourage something in between Q&A and discussion points from the audience, something along those lines. Okay, so when I say reframing superintelligence, what I mean is thinking about the context of emerging AI technologies as a process rolling forward from what we see today, and asking what does that say about likely paths forward, such that whatever it is that you're imagining needs to emerge from that context or in that context, which I think reframes a lot of the classic questions. Most of the questions don't go away, but the context in which they arise, the tools available for addressing problems look different, and well, that's what we'll be getting into. So once upon a time, when we thought about advanced AI, we didn't really know what AI systems were likely to look like. It was very unknown. People thought in terms of developments in logic and other kinds of machine learning, different from the deep learning that we now see moving forward with astounding speed. And people reached for an abstract model of intelligent systems. And what intelligent systems do we know? Well, actors in the world like ourselves, we abstract from that very heavily, and you end up with rational utility-directed agents. Today, however, we have another source of information beyond that kind of abstract reasoning, which applies to a certain class of systems. And the information that we have comes from the world around us, what's happening, how AI systems are developing. And so we can ask questions like, where do AI systems come from? Well, today they come from research and development processes. We can ask, what do AI systems do today? Well, broadly speaking, they perform tasks, which I think of or will describe as performing services. They do something, some approximation, or they do something that someone supposedly wants in bounded time with bounded resources. What will they be able to do? Well, if we take AI seriously, AI systems will be able to automate asymptotically all human tasks and more, at a piecemeal and asymptotically general superintelligent level. So, said AI systems come from research and development. Well, what is research and development? Well, it's a bunch of tasks to automate. And in particular, they're relatively narrow technical tasks, which are, I think, uncontroversially automatable on the path to advanced AI. So the picture is of AI development moving forward, broadly along the lines that we're seeing, higher level capabilities, more and more automation of the AI R&D process itself, which is an ongoing process that's moving quite rapidly. AI-enabled automation, and also classical software techniques for automating AI research and development. And that, of course, leads to acceleration. Where does that lead? Leads to something like recursive improvement, but not the classic recursive improvement of an agent that is striving to be a more intelligent, more capable agent, but instead recursive improvement where an AI technology base is being advanced at AI speed. And that's a development that can happen incrementally. We see it happening now. As one takes steps toward advanced AI that is applicable to increasingly general and fast learning, well, those are techniques that will be inevitably be folded into the ongoing AI R&D process. Developers, given some advance in algorithms and learning techniques, conceptualization of how to address more and more general tasks, will pounce on those and incorporate them into a broader and broader range of AI services. So where that leads is to what are asymptotically comprehensive AI services, which crucially includes the service of developing new services. So increasingly capable, increasingly broad, increasingly piecemeal and comprehensively superintelligent systems that can work with people, interact with people in many different ways to provide the service of developing new services. And that's a kind of generality. That is a general kind of artificial intelligence. So a key point here is that the C in CASE, C in comprehensive AI services, does the work of the G in AGI. Why is it a different term? To avoid the implication, when people say AGI, they mean AGI agent. And we can discuss the role of agents in the context of this picture, but I think it's clear that a technology base is not inherently in itself an agent. In this picture, agents are not central. They are products. They are useful products of diverse kinds for providing diverse services. And so with that, I would like to, as I said, it was a formal part here will be short, point to a set of topics. They kind of break into two categories. One is about short paths to superintelligence. I will argue that this is the short path. Topic of AI services and agents, including agent services, versus the concept of the AI, which looms very large in people's concepts of future AI. I think we should look at that a little bit more closely. Superintelligence as something distinct from agents, superintelligent non-agents, and the distinction between general learning and universal competence. People have, I think, misconstrued what intelligence means. I'll take a moment on that. If you look at definitions of, good from the 1960s, ultra-intelligence, and more recent, Bostrom and so on, I work across the hall from Nick, on superintelligence, the definition is something like a system able to outperform any person in any task whatsoever. Well, that implies general competence, at least as an ordinarily read. But if we ask, we call children intelligent, and we call senior experts intelligent. We call a child intelligent because the child can learn, not because the child can perform at a high level in any particular area. And we call an expert who can perform at a high level intelligent, not because the expert can learn. In principle, you could turn off learning capacity in the brain, but because the expert can solve difficult problems at a high level. So learning and competence are dissociable components of intelligence. They are, in fact, quite distinct in machine learning. There's a learning process, and then there's an application of the software. And when you see discussion of intelligent systems that does not distinguish between learning and practice, treats action as entrailing learning directly, there's a confusion there. There's confusion about what intelligence means, and that's, I think, very fundamental. In any event, looking toward safety-related concerns, there are things to be said about predictive models of human concerns, AI-enabled solutions to AI control problems, how this reframes questions of technical AI safety, issues of services versus addictive services and adversarial services. Services include services you don't want. Taking superintelligent services seriously, and a question of whether faster development is better. And with that, I would like to open for questions, discussion, comment. I would like to have people come away with some shared sense of what the questions and comments are, some common knowledge of thinking in this community in the context of thinking about questions this way. So,
so is your model compatible with end-to-end reinforcement learning?
Yes.
Thank you.
to say a little bit more. Just by the way, there's a collection. I've been working on a collection of documents for the last 2 years. It's now very large. It will be an FHI technical report soon. It's 30,000 words, structured to be very skimmable. Top-down, hierarchical, declarative sentences, expanding into longer ones, expanding into summaries, expanding into fine-grained topical discussion. So you can sort of look at the top level, say, hopefully, yes, 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 what about this, and not have to read anything like 30,000 words. So what I would say is that reinforcement learning is a technique for AI system development. You have a reinforcement learning system. It produces, through a reinforcement learning process, which is a way of manipulating the learning of behaviors, produces systems that are shaped by that mechanism. So it's a development mechanism for producing systems that provide some service. Now, if you turned reinforcement learning loose in the world, open-ended, read-write access to the internet, a money maximizer, and did not have checks in place against that, there are some nasty scenarios. So basically, it's a development technique, but could also be turned loose to produce some of the kinds of global, creative systems trying to manipulate the world in bad ways. Scenarios are another sector of reinforcement learning. So not a problem per se, but one can have problems using that technique.
And then a clarification question. What does asymptotic improvement of AI services mean?
I think I'm abusing the term asymptotic. What I mean is increasing scope and increasing level of capability in any particular task to some, comprehensive is sort of like saying infinite, but moving toward comprehensive superintelligent level services says what it's intended to say is ongoing process going in that direction. And just sort of, if someone has a better word than asymptotic to describe that, I'd be very happy.
Can the tech giants like Facebook and Google be trusted to get alignment right?
Google more than Facebook. We have that differential. I think that questions of alignment look different here. I think it's more. I think more in terms of questions of application. What are the people who wield AI capabilities trying to accomplish? So there's a picture, which just background to the framing of that question. And a lot of these questions, I think, I'll be stepping back and asking about framing, as you might think from the title of the talk. So picture a rising set of AI capabilities: image recognition, language understanding, planning, strategic, tactical management in battle, strategic planning for patterns of action in the world to accomplish some goals in the world, rising levels of capability in those tasks. Those capabilities could be exploited by human decision makers, or could, in principle, be exploited by a very high-level AI system. I think we should be focusing more, not exclusively, but more on human decision makers using those capabilities than on high-level AI systems, in part because human decision makers, I think, are going to have broad strategic understanding more rapidly. They'll know how to get away with things without falling afoul of what nobody had seen before, which is intelligence agencies watching and seeing what you're doing. It's very hard for a reinforcement learner to learn that kind of thing. So I tend to worry about not the organizations making aligned AI so much as whether the organizations themselves are aligned with general goals, which will be the subject of the talk I'm giving at 3 on Paretopian goal alignment. And actually I have a few slides appended to this that I can show you at some point. I'm going to have a little bit of overlap between the talks.
Could you describe the path to superintelligent services with current technology? So some more concrete examples.
Well, we have a lot of piecemeal examples of superintelligence. AlphaZero is superintelligent in the narrow domain of Go. There are systems that outperform human beings in playing these very different kinds of games, Atari games, face recognition, recently surpassing human ability to map from human speech to transcriptive words. Just more and more areas piecemeal. A key area that I find impressive and important is the design of neural networks at the core of modern deep learning systems. the design of and learning to use appropriately, hyperparameters. So as of a couple of years ago, if you wanted a new neural network, a convolutional network for vision, or some recurrent network, though recently they're going for convolutional networks for language understanding and translation, that was a handcrafted process. You had human judgment and people were building these networks. A couple of years ago, people started in these, this is not AI in general, but it's a chunk that a lot of attention went into, getting superhuman performance in neural networks by automated, AI-flavored, like, for example, reinforcement learning systems. So developing reinforcement learning systems that learn to put together the building blocks to make a network that outperforms human designers in that process. So we now have AI systems that are designing a core part of AI systems at a superhuman level. And this is not revolutionizing the world, but that threshold has been crossed in that area. And similarly, automation of another labor-intensive task that I was told very recently by a senior person at DeepMind would require human judgment. My response was, do you take AI seriously or not? And out of DeepMind itself, there was then a paper that showed how to outperform human beings in hyperparameter selection. So those are a few examples. And the way one gets to an accelerating path is to have more and more, faster and faster implementation of human insights into AI architectures, training methods, and so on. Less and less human labor required to do that. Higher and higher level human insights being turned into application throughout the existing pool of resources, and eventually fewer and fewer human insights being necessary. Yeah.
So what are the consequences of this reframing of superintelligence for technical AI safety research?
Well, recontexting. It says in part that let's look over here. If in fact one can have superintelligent systems that are not inherently dangerous, then one can ask how one can leverage, high-level AI, abusing the word asymptotically superintelligent systems, and applying to technical AI safety problems. So a lot of the classic scenarios of misaligned powerful AI involve AI systems that are taking actions that are blatantly undesirable. And as Shane Legg said when I was presenting this at DeepMind last fall, there's an assumption that we have superintelligence without common sense. And that's a little strange. So Stuart Russell has pointed out that machines can learn not only from experience, but from reading. And one can add watching video and interacting with people and through questions and answers in parallel over the internet. And we see in AI that a major class of systems are predictive models. Given some input, you predict what the next thing will be. The next in this case, given a description of a situation or an action, you try to predict what people will think of it. Is it something that they care about or not? And if they do care about it, is there widespread consensus that that would be a bad result? Widespread consensus that it would be a good result? Or strongly mixed opinion? So if one has a predictive model of that, it's a predictive model trained on many examples, it's not an agent, that is an oracle that in principle could operate with reasoning behind the prediction, that could in principle be operate at a super intelligent level, and would have common sense about what people care about. Now think about having AI systems that you intend to be aligned with human concerns. Where available for a system that's planning action is this oracle. It can say, well, if such and such happened, what would people think of it? And you'd have a very high quality response. That's a resource that I think one should take account of in technical AI safety. We're very unlikely to get high-level AI without having this kind of resource. People are very interested in predicting human desires and concerns only because they want to sell you products or brainwash you in politics or something. And that's the same underlying AI technology base. So I would expect that we will have predictive models of human concerns. That's an example of a resource that would reframe some important aspects of technical AI safety.
So making AI services more general and powerful involves giving them higher level goals. At what point of complexity and generality do these services then become agents?
Well, many services are agent services. A chronic question that arises, people will be at FHI or DeepMind, and someone will say, well, what is an agent anyway? And everybody say, well, there's no sharp definition, but over here we're talking about agents, and over here we're clearly not talking about agents. So I would be inclined to say that if a system is best thought of as directed toward goals, and it's doing some kind of planning and interacting with the world, I'm inclined to call it an agent. And by that definition, there are many, many services we want, starting with autonomous vehicles, autonomous cars and such, that are agents. They have to make decisions and plan. So there's a spectrum from there up to higher and higher level abilities to do means ends analysis and planning and to implement actions. So let's imagine that your goal is to have a system that is useful in military action, and you would like to have the ability to execute tactics with AI speed and flexibility and intelligence, and have strategic plans for using those tactics that are super intelligent level. Well, those are all services. They're doing something in bounded time with bounded resources. And I would argue that that set of systems would include many systems that we would call agents, but they would be pursuing bounded tasks with bounded goals. That the higher levels of planning would naturally be structured as systems that would give options to the top-level decision makers who would not want to give up their power. They don't want a system guessing what they want. At a strategic level, they have a chance to select. Strategy unfolds relatively slowly. So there would be opportunities to say, well, don't guess, but here's the trade-off I'm willing to make between having this kind of impact on opposition forces with this kind of lethality to civilians and this kind of impact on international opinion. I would like options that show me different trade-offs, all very high quality, but within that trade-off space. And here I'm deliberately choosing an example which is about AI resources being used for projecting power in the world. I think that's a challenging case. It is a good place to go. I'd like to say just a little bit at the opposite end briefly, superintelligent non-agents. Here's what I think is a good paradigmatic example of superintelligence and non-agency. Right now we have systems that do natural language translation. You put in sentences, or if you had a somewhat smarter system, dealt with more context, books, and out comes text in different language. Well, I would like to have systems that know a lot to do that. You do better translations if you understand more about history, chemistry if it's a chemistry book, human motivations. You'd like to have a system that knows everything about the world and everything about human beings to give better quality translations. But what is this system? Well, it's a product of R&D, and it is a mathematical function of type string, character string to character string. You put in character string, things happen, and out comes a translation. And you do this again, you do this again, and you do this again. Is that an agent? I think not. Is it operating at a super intelligent level with general knowledge of the world? Yes. So I think that one's conceptual model of what high-level AI is about should have room in it for that system and for many systems that are analogous.
Would a system service that combines general learning with universal competence not be more useful or competitive than a system that displays either alone? So does this not suggest that agents might be more useful?
Okay. Well, as I said, agents are great. The question is what kind and for what scope. So I was saying, distinguishing between general learning and universal competence is an important distinction. I think it is very plausible that we will have general learning algorithms. And general learning algorithms may be algorithms that are very good at selecting algorithms that are good at selecting algorithms for learning a particular task and inventing new algorithms. Now, given an algorithm for learning, there's a question of what you're training it to do, what information, what competencies are being developed. And I think that the concept of a system being trained on and learning about everything in the world with some objective function, I don't think that's a coherent idea. What is, let's say you have a reinforcement learner. you're reinforcing the system to do what? Here's the world, and it's supposed to be getting competence in organic chemistry and ancient Greek, and I don't know, control of the motion of tennis playing robots, and on and on and on and on. What's the reward function, and why do we think of that as one task? I don't think we think of it as one task. I think we think of it as a bunch of tasks which we can construe as services, including the service of interacting with you, learning what you want, nuances, what you are assumed to want, what you're assumed not to want, as a person, more about your life and experience, and very good at interpreting your gestures, and can go out in the world and, subject to constraints of law and consulting an oracle on what other people are likely to object to, implement plans that serve your purposes. And if they're important and have a lot of impact, within the law, presumably, what you want is for that system to give you options before the system goes out and takes action. And some of those actions would involve what are clearly agents. So that's the picture I would like to paint that I think reframes the context of that question.
So on that, so is it fair to say that the value alignment problem still exists within your framework, since in order to train a model to build an agent that is aligned with our values, we must still specify our values?
Well, what do you mean by train an agent to be aligned with our values? See, the classic picture says you have the AI, and the AI gets to decide what the future of the universe looks like, and it better understand what we want or would want or should want or something like that, and then we're off into deep philosophy. And my card says philosophy on it, so I guess I'm officially a philosopher or something, according to Oxford. I was a little surprised. It says philosophy on it. Cool. I do what I think of as philosophy. So in a services model, the question would instead be, here's what do you want to do? Give me some task that is completed in bounded time with bounded resources, and we can consider how to avoid making plans that stupidly cause damage that I don't want, plans that by default automatically do what I can be assumed to want, and that pursue goals in some creative way that is bounded in the sense that it's not about reshaping the world. Other forces would presumably try to stop you. And I'm not quite sure what value alignment means in that context. I think it's something much more narrow and particular. Oh, by the way, if you think of an AI system that takes over the world, keep in mind that a subtask of that, part of that task, is to overthrow the government of China. And presumably succeed the first time, because otherwise they're going to come after you if you made a credible attempt. And that's in the presence of unknown surveillance capabilities and unknown AI that China has. So you have a system, and well, it might formulate plans to try to take over the world. Well, I think an intelligent system wouldn't recommend that because it's a bad idea. Very risky, very unlikely to succeed. Not an objective that an intelligent system would suggest or attempt to pursue. So you're in a very small part of scenario space where that attempt is made by a high-level AI system, and it's a very small part of scenario space because it's an even smaller part of scenario space where there is substantial success. I think it's worth thinking about this. I think it's worth worrying about it, but it's not the dominant concern. It's a concern in a framework where I think we're facing an explosive growth of capabilities that can amplify many different purposes, including the purposes of bad actors. And we're seeing that already, and that's what scares me.
So I guess in that vein, so could these superintelligent services be used to take over the world by a state actor, so just the services?
Well, services include tactical execution of plans and strategic planning. And if there is a way for a state actor to do that using AI systems in the context of other actors with presumably a comparable level of technology, maybe so. And I think that is a good reason to give some overlapping slides with the talk that I'm going to be giving at 3, which is about goal alignment. The assumption there is that a state actor might want to try to do that, but it's obviously a very risky thing to do. So just to step into that area. So key considerations for forward-looking AI strategy. AI, very, 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 very important. Why? in part because it will lead to a situation in which, well, so important, and the important point here is that at some point, explosive growth will be close enough to be credible and to be understood to be within the planning horizons of more and more and more real-world actors and institutions. One aspect of powerful AI is an enormous expansion of productive capacity, partly through, for example, high-level, high-quality automation. More realistically, physics-limited production technology, which is outside today's sphere of discourse or Overton window. Security systems, I will assert, could someday and potentially be both benign and effective, stabilizing. So, argument is that eventually it would be visibly the case that we'll have, superintelligent level, very broad AI, enormous productive capacity, and the ability to have strategic stability if we take the right measures beforehand to develop appropriate systems or to be prepared to do that and to have aligned goals among many actors. So these are outside the Overton window of policy discourse, outside the range of what can be discussed. And so the first set of facts says we can have an approximately strongly Pareto-preferred world, a world that looks pretty damn good to pretty much everyone. And fact 4 says that strategies for getting there are constrained by the fact that you can't really talk about the underlying premises seriously. And this is much of what I'm going to be talking about in the Paretotopian goal alignment talk at 3. But quickly, resource competition is central. It's the zero-sum part. It's like a zero-sum game. And here we have two axes, quantity of stuff, some finite resource that A gets, quantity of stuff that B gets. The constraint line is unit quantity. And so we have this nice straight diagonal line, and I've shown 50-50 current holdings, just as an example situation one might be in. The usual assumption is that resources are fixed or growing slightly, so it doesn't make a whole lot of difference that they're growing, and so you have this kind of conflict. I want more, that means you get less, approximately zero sum. If we think about utility, though, we should be thinking about utility, not quantity of resources, then people often think of quantity of something, the utility is something like the logarithm of that quantity, money, or I'm going to say resources here. And that gives us, well, first of all, here's what expansion by 50% looks like. You're still largely, the question is back and forth, where do you end up on this, strong trade-offs. Here's B taking all the gains, here's B taking 90% of the total, actually taking away from A. So putting this into the world of utility, we replot the same curves on a log scale, and we get curved lines, and they look like this. And there's our 50% expansion again. Qualitatively, it looks rather similar. The question is, what happens if you have a large expansion of resources? What if you are in a situation where, for the first time in history, it's possible to see, within a decision-making planning horizon, that there are opportunities for an enormous expansion of these rivalrous goods, resources? Well, same curves are shown there in the lower left. And here's what a factor of 1,000 expansion looks like. Notice that all the gains versus 90% have swapped positions. Now someone can take 90%. You get a smaller fraction of the resources, and you're still much, much better off. What's important is that you share the gains in some way that's reasonable. Now, in that picture, this is small. The incentives for grabbing everything are relatively small. And they're also risky. If you try to get from current holdings to all the gains, you're going to get a lot of opposition. If you aim for some place that is relatively fair, maybe one can have goal alignment and a lot of different parties saying, yes, let's go there. And so the argument is that greed brings risk, and here are places you might end up if you are one of these actors and trying to get to different places. The very unfair outcomes are likely to get opposition. You're less likely to succeed, so this is the risk-adjusted gains or payoff. And then the associated with this, well, here's a region. This region is labeled Paretotopia. Sort of like utopia, except without the implication that everybody is in the ideal society, whether they want it or not. It's instead defined to be a set of conditions that look pretty good to pretty much everyone. The sorts of world outcomes that could, in fact, align the goals of powerful actors. And that's why I brought this up in the context of states trying to take over the world. This says that's dangerous, and there's very little reward to doing so if you have the option of having security, not by dominance, but by developing secure systems. And the argument is that, in fact, forward-looking in the context of superintelligence does objectively make that possible. The problem is to have decision makers have that be within their sphere of discourse and see it as an attractive option when the decisions are made downstream. And that's what the following talk is about. Let me go back to
So then in the context of that, what do you think the greatest AI threat to society then in the next 10, 20 years would be?
I think the greatest threat is instability, sort of either organic instability from AI technologies being diffused and having more and more of the economic relationships and other information flow relationships among people be transformed in directions that increase entropy, generate conflict, destabilize political institutions. Who knows? If you had the internet and people were putting out propaganda that was AI enabled, it's conceivable that you could move elections in crazy directions in the interests of either good actors or bad actors. Well, which will that be? I think we will see efforts made to do that. What kinds of counter pressures could be applied to bad actors using linguistically, politically competent AI systems to do messaging? And of course, there's the perennial states engaging in an arms race, which could tip into some unstable situation and lead to a war, including the long postponed nuclear war that people are waiting for and might in fact turn up someday. So I primarily worry about instability. Some of the modes of instability are because some actor decides to do something like turn loose a competent hacking reinforcement learning system that goes out there and does horrible things to global computational infrastructure that either do or don't serve the intentions of the parties that released it, but take a world that's increasingly dependent on computational infrastructure and just slice through that in some horribly destabilizing way. So those are some of the scenarios I worry about most.
And then maybe longer term than 10, 20 years?
Longer term?
I mean, if the world isn't over by then?
Well, I think all of our thinking should be conditioned on that. If one is thinking about the longer term, one should assume that we are going to have superintelligent level general AI capabilities. Let's define that as the longer term in this context. And if we're concerned with what to do with them, that means that we've gotten through the process to there then. So two questions. One is, what do we need to do to survive or have an outcome that's a workable context for solving more problems? And the other one is what to do. So if we're concerned with what to do, we need to assume solutions to the preceding problems. And that means high-level superintelligent services. That probably means mechanisms for stabilizing competition. That there's a domain there that involves turning surveillance into something that's actually attractive and benign. And the problems downstream, therefore, one hopes to have largely solved, at least the classic large problems, and now problems that arise are problems of, what is the world about anyway? We're human beings in a world of superintelligent systems. Is transhumanism in this direction, uploading in this direction, developing, moral patients, superintelligent level entities that really, aren't just services. They're the moral equivalent of people. What do you do with the cosmos? It's an enormously complex problem, and from the point of view of having good outcomes, what can I say? There are problems.
So what can we do to improve diversity in the AI sector, and what are the likely risks of not doing so? I'm not sure exactly what diversity means in this context, but...
Well, I don't know. My sense is that what is most important is having the interests of a wide range of groups be well represented. To some extent, obviously that's helped if you have in the development process in the corporations people who have these diverse concerns. To some extent, it's a matter of politics, regulation, cultural norms, and so on. I think that's a direction we need to push in. To put this in the Pareto-topian framework, if your aim is to have objectives, goals that really are, aligned, possible futures that are strongly goal aligning for many different groups, those groups' concerns, which we don't fully understand. I'm over here, do I fully understand the concerns of that group? No. Need to have some joint process that produces an integrated, adjusted picture of, for example, how do we have EAs be happy and the billionaires maintain their relative position, because if you don't do that, they're going to maybe oppose what you're doing, and the point is to avoid serious opposition, and also have the government of China be happy. And I would like to see the poor in rural Africa, the billionaires be way up here, and they're now competing not to build orbital vehicles but starships. And the poor in rural Africa of today merely have orbital space capabilities convenient for families. They're poor.